And then we're going to start the next section today. Yep, 309. So before we finish up these graphs, I just want to take a second and show you guys where we are in this unit. All right, we're going to finish graphing today. We just have 2 more examples, so it shouldn't take us that long to do. We're going to start the next section today, and I believe we should be able to finish it on Monday, okay? Which means Tuesday would be free response day, Wednesday will be a partner quiz, Thursday will be your review day, and then test Friday, and then the following Monday. I typically don't like to give a test like over a weekend, but it seems like that's just how the timing is going to work out for this one. Okay, so I'm letting you become prepared. So quiz Wednesday next week, test part 1 on Friday, and then part 2 on Monday. All right, so you can make note of those. Bless you. All right, let's take a look at number 3. We were talking about transformations yesterday for these exponential functions where we're flipping and moving left, right, up, down. And we took a look at 2 examples yesterday. Bless you. We're going to do 2 more today. Can we identify the parent graph for number 3? What do you think? Yeah. There we go. You're just trying to identify what the base is. So a very simple parent function, 1/2 to the x. Those are the starting points that we're going to use from that graph. And then we're going to move them somehow based off of the transformations we can identify from the equation. So in your head, or maybe you actually want to write it on the paper, you can cross off the 1/2 and the x. Everything else is some type of change that we need to list. Okay, so from yesterday, can we identify any changes? Yeah. There we go. We have a negative on the outside. X-axis flip. Anything else? Yeah. Right 2. Okay, that's the -2 in the power spot that's causing that change. And what about the +2 on the end? Yeah. Up 2. Good. All right, so if those are the transformations, we're going to take a regular coordinate from the parent graph, okay, an x and a y, and we're going to change those coordinates based off of those transformations. So x-axis flip, which variable does it affect, and how does it affect it? Yeah? Y becomes negative, good. If you move a graph or an ordered pair right 2 units, which variable does it affect? Yeah? X, right? And we're moving it to the right, so we're going to add 2 units. And then what about the up 2? Yeah. We got a +2. All right. Are we okay with those ordered pair values? Okay, so our first job is to try to figure out some points on the parent function. So yesterday we did this kind of on the front page. Actually, this one I think was on the back of the front page. But what I want you to just think about are plugging in easy x values into the parent function to get some ordered pairs. If we were to plug in -2 in for that x, yeah, we'd get 4. Perfect. If we were to plug in -1 into that x, we would get 2. If we plug in 0, we get 1. And if we plug in 1, we get a half, and if we plug in 2, we get a fourth. Okay, we saw those ordered pairs from yesterday. So those ordered pairs come from the parent graph. Let's go ahead and use our new coordinates, those rules that we wrote down, to figure out where the points are on this new graph. So we'll go ahead and plug in -2 for x, 4 for y, and see what we get. Once you have your new ordered pairs, you can go ahead and plot them on the graph. Can we identify where our horizontal asymptote should be? Yeah, good. Alright, so connect the dots, and we have our exponential graph. Now that we have a picture, let's go ahead and label domain and range. Drag your pencil left, right, low to high. What do you think? Yeah. Perfect. And you want to do the range too? To 2. Perfect. Did we lose it from yesterday? I hope not. Do you guys think you can try the next one, number 4? Really similar. Just so we're all on the same page, is this moving left 3 or right 3? What do you think? Yeah. How do you know? There we go. Okay, so if that negative wasn't there, it would move left 3. But since the negative is there, it's affecting that translation, so it's a moving right. It flips it. Good. Where can we draw the asymptote? Yeah, -1. And let's see, based off that graph, domain would be -infinity to +infinity, and range -infinity to -1. How'd you do? Pretty good? All right. Okay, so we're going to skip over to the last section on page 315. This section, last one, is more of like a review unit. We're going to take a look at exponential functions in different forms, like a table, a graph, an equation, and we're just going to try to write down everything we can about that exponential function based off the information that we're given. Okay, so we're going to practice and kind of think about all the different characteristics and relationships we've talked about in this unit. Okay, so the first one on page 315 is a table, and they give us kind of the general form of the exponential function that would give us this table. So looking at the table, maybe the equation, what are some things we can write down that we know about this exponential function? Is it growth? Is it decay? Where's the horizontal asymptote? Is the a value positive or negative? Is the b value between 0 and 1 or greater than 1? Can we figure out the equation? Okay, can we fill in a, b, and c? Can we figure out domain and range? Can we figure out any transformations? Okay, a lot of different pieces of information we're going to try to identify. So what do you think right now, just by looking at it, something that we can identify fairly quickly? Yeah. How'd you know?
Because if you look at the y values to the left,
yep,
it's approaching -1.
There we go. All right, so horizontal asymptote at -1 because we'll say approaching to the left. Okay. If our horizontal asymptote is at -1, do we know where that value shows up in the equation? Yeah.
It's C.
That's the C value. All right. So we'll also say C is -1. Perfect. Okay. Anything else? Yeah.
It would be a growth function since it's going away from the horizontal asymptote.
There we go. Growth because moving away from HA, horizontal asymptote, to the right. I like it. Anything else? You see something, Ashlyn? Yeah.
What the, how it says it shows in the equation the y-axis.
Okay, so maybe we'll go ahead and label this right now. We have a y-axis flip. Once we figure out, so we know what C is, once we possibly figure out what A is, we could write some other transformations, but we are going to come back to that. Okay, so there definitely is a y-axis. Go ahead, Tori. How do we find C? That's where the horizontal asymptote is. So notice on the left-hand side, that's what you're approaching. That's okay. Go to Rebecca, you see something else?
The b value, I think, is between 0 and 1, like for the parent function, that is.
How'd you know?
Because, well, the y-axis flip would change it from decay to growth, which is why it's growth.
Okay. So we got to figure out what this b value is. We know the ending graph is growth, but we also identified a y-axis flip from Ashlyn. Okay, so if you think about a decay graph and you were to flip that left and right, it would now look like that, right? Which is growth. So maybe we'll go ahead and label the b value is between 0 and 1 because Rebecca mentioned that there was a y-axis flip. You see something else? Yeah.
We can find out
The A value is 3?
Yes.
How'd you get that?
Well, because in order to get b set to 1,
Mhm.
you fill in 2
Yeah.
to get a 0, and it would just square it to 1. So when you do that, you add c onto the opposite side. So
Okay, we're going to find out the A value in a little bit. So Marie thinks the A value is 3. Can we identify, at least first of all, if the A value is positive or negative? did we have an x-axis flip? How can you tell? Yeah?
Oh wait, sorry, let me go back.
It's okay, but yeah.
It would be positive because if there wasn't an x-axis, but then it stays above the horizontal axis.
Okay, so we said the horizontal asymptote was at -1, correct? If you look at all of your y values, are all of those above -1? They're below, right? Signifying a negative a value. Okay, so we'll say a is negative because all y values are smaller or below, maybe we'll say below instead of smaller, are below the horizontal asymptote. Okay, so Marie thought the a value was 3. Maybe it's -3. Okay, but at least we should know it should be a negative value. Okay, so speaking of trying to figure out these values, let's go ahead and give that a shot. Okay, we'll go ahead and find a, b, and c values. Now we already know c is -1 from before. And Marie mentioned trying to pick some strategic points to help us figure out A, B, and C. What was the point you used again, Marie?
2.
X value of 2, Y value of -2. And why did you pick that one again?
Because it would set the power to 0.
It would make the power 0, which would make b to the 0 turn to 1, and a times 1 would just be a. So by setting the power to 0, you're eventually eliminating that b value. So let's go ahead and solve for a. We have -2 for the y. We don't know a. We would have b to the -2 plus 2 power, and our c value was -1. All right, so we said this would be b to the 0, which would go away. And if we add 1 to the other side, we'll get -1. Checks out from what we said before, right? A should be negative? Yeah.
I have a question.
Yeah.
It wouldn't be 2 if it would result in a
Say,
like my whole thing with the equation is that it was powered by -x, y, just assumed it would be regular 2 because equation 2.
you're talking about this part right here? Okay, so if you look at the equation, we have the negative out front, and we're plugging in a 2, so that's going to make it a -2 plus 2.
Yeah, but I know, but I just thought it'd be a regular 2 on the opposite side.
Oh, a regular 2. Oh, that's how you got 3 from before. Okay, so maybe it was just a copy error. Okay, so -2 on the other side because of that guy. Okay? All right, let's go ahead and try to see if we can figure out a b value. Okay, can we pick another strategic point to possibly use? Is there any other easy point in the table? Not quite, right? Okay. Let's perhaps choose, it doesn't really matter because you can just pick any point you want. Maybe we'll do the 5 and the -16.3. Now since that's a decimal, we may have to use a calculator to help us out. So if you do have one available, go ahead and grab it. Let's go ahead and choose the 5 and -16.63. Alright, so y value is -16.63. A value we just found was -1. B value, we're trying to figure that out. In the power, we'll have -5 plus 2. And we need a -1 on the outside. All right, so we're going to try to solve for b. Maybe we can add the 1 to the other side. And we can simplify the power on the b. That would be -3. Let's go ahead and divide the -1 over, okay, that a value that we found. How can we make that negative power positive? Yeah? We can flip it, yep, we'll make it a fraction. All right. Let's go ahead and we can multiply the b cubed over. We can divide the 15 value. And then how are we going to get rid of a power of 3? Heard it? A cube root. Okay, so on your calculator, we know the square root button is right above the x squared, but there is a cube root menu option that you can choose. If you hit math, do you notice option 4? You see how it has that 3 with the check mark? Okay, if you select that, that will be a cubed root on your calculator, and you can go ahead and type in 1 over 15.63. So maybe we'll round that to 0.4. Does our b value make sense? We said up here it should be between 0 and 1, right? Checking out, okay? So let's go ahead and put everything together. We'll write the final equation. This was labeled capital H of x. Our a value was -1. Our b value was 0.4. Our power is -x plus 2. And we had a -1 on the end. All right. There are two more things that I think we can jot down about this exponential function. Now that we know the entire equation, can we identify any more changes? Ashlyn started out with the y-axis flip from the top, which was great. But now that we know all the numbers, maybe we can find a few more. Okay, so we'll go ahead and write down y-axis flip. Any other changes based off that equation? Good, Marie? There's also an x-axis flip. Yep, that -1 out front. Anything else? Keep going, yeah?
Shift down.
Down 1. Yeah. Right 2. Perfect. Okay. Can we identify the parent function? What was the beginning graph we had before we did all that changing? Yeah?
0.4.
There we go, 0.4 to the x. Okay. Based off those transformations, can we write our ordered pair rule? How it affects the x and y coordinate? You guys are on a roll. This is great. Yeah.
Negative x plus 2.
Uh-huh.
And then negative y minus 1.
Wonderful. All right. Last but not least, we're going to do domain and range. Maybe you can utilize the table to help you with that. How far left and right do you think this exponential function will go? Maybe you started to see a pattern with the graphs we did today and yesterday. Yeah. It's always all real numbers. Perfect. The range is what changes because it depends where your asymptote is and whether you're above or below it. Okay, can we figure out the range? Yeah?
Could be negative infinity to -1.
Perfect. You guys did great. Anything else you want to add? I think we covered all of our bases. All right, we're going to try another one the exact same way. We just might start with a different piece of information, okay? So let's go ahead and check out the first one here. This time we have a graph instead of a table, and they're giving us kind of a format of the equation to use. Let's go ahead and jot down anything we could possibly identify from this piece. Yeah? C equals what?
3.
Because?
Because it's the horizontal asymptote.
That's your horizontal asymptote. Okay. Yeah.
It would be a decay function since it's going towards the horizontal asymptote.
There we go. Decay because moves towards asymptote to the right. Okay. Ashlyn, did you have another one, or is that what you were going to say? You were going to say that one? Okay. Can we figure out if A is positive or negative, if B is between 0 or 1 or greater than 1? Right, Rebecca?
I think A would be negative because it's below.
There we go. So A is negative, aka less than 0, if you want to use mathematical notation, because we are below the horizontal asymptote. Perfect. Yeah?
There's also a y-axis function since it's -2. Like x equals -2.
Okay, so you know that -2 up here would make the power 0, right? But the fact is we're not starting with a negative in there, okay? So there's no negative listed. We'll get to the translation or transformations in a little bit. We just got to figure out some other numbers first. Can we tackle the B value? Yeah?
It would be between 0 and 1 because it's decay.
All right. So Hannah's saying we're starting with a decay graph above the x-axis, and if we were to flip it upside down, remember that A value out front was negative, signifying an x-axis flip, it would now look like this, which matches the graph we have. So if we're starting with decay, the B value must be between 0 and 1. So we'll say because we have an x-axis flip. Looks good. All right, so now that we have an idea about what A and B should be, maybe we can figure them out exactly. Okay, so we already know the C value is 3. Can we strategically pick a point to help us figure out A or B? Keeping in mind we want to get that power to be 0. Yeah?
-2, 2.
-2, 2. Yep, that ordered pair on the graph. All right, so let's check it out. 2 equals A times B to the -2 plus 2 power, and we said the C value was plus 3 on the end. So 2 equals A plus 3. The B value is going to go away. Power of 0. And looks like A is -1 again. Does that make sense based off of what we said? Should be negative, right? Let's go ahead and pick another point to help us figure out B. So looking at the graph, can you find another nice, easy ordered pair to use? Go, Tori. -6, -2. Yep, you could use negative, or no, not quite. I thought -4 would work. Doesn't look like it's 1 exactly. Let's go ahead and use that one. -6, -2. Okay. So we have -2 equals -1 times B to the -6 plus 2 power, and then a plus 3 on the end. Alright, if we subtract the 3 over, we'll get negative 5. And then the power on the b would be negative 4. We can divide the negative 1 over. Let's change the negative power positive. We'll turn it into a fraction. We can multiply the b to the 4th over. And then divide the 5. How are we going to get rid of a power of 4? What are we going to do? Yeah? A 4th root. Okay, so I'm going to show you how to do that on your calculator. Okay? If you go to math, for the previous example we chose option 4 because that was a cubed root. Do you notice how option 5 is the xth root? If you select option 5 and move your cursor to the left, wherever that ANS is, you can delete that out. Hit the delete button, and you can type in 4. So you can take any root you want. In this case, we want the 4th root, and we'll do 1 divided by 5. Maybe we'll say that's 0.7. We'll round it. Okay. Alright, so let's go ahead and put everything together. We have capital F of x equals negative 1 times 0.7 to the x plus 2 power with a plus 3 on the end. Hopefully that b value makes sense because we said it should be between 0 and 1. Checking out. Alright, we're running a little bit out of room here. We're going to go into the next block a little bit. Based off of that equation, now that we know all the numbers, can we identify any changes? Left, right, up, down, flips. Yeah. X-axis flip. You want to keep going? Yeah. Okay. Left 2, up 3. Can we list the parent function? Good, Rebecca?
If you 0. Well, I just rounded it to the 100. So
That's fine.
It'd be like 0.67.
That's fine.
To the x.
To the x power, yep. Okay, based off those transformations, let's write the ordered pair rule, how the x's and y's are affected. Yeah.
X minus 2.
Okay. You want to keep going?
Y plus 3.
We would need a negative y because of the x-axis flip. Good. Y, negative y plus 3. Perfect. All right, last but not least, domain and range. They actually give us a graph, so maybe this would be a little bit easier for us to identify. How far left and right, low to high? Yeah.
Negative infinity to positive infinity.
Okay.
Negative infinity to 3.
Perfect. All right. We're doing okay? We did a lot with those two graphs. Okay, we just kind of combined everything we did for this unit in 2 problems. Okay, so pencil drop, we're done for the day.